Dear students, we are going to start subject analog circuits. This is first lecture of this subject. So in this subject we will first of all discuss on introduction of this subject. And we can see from its name it contains two words, analog circuits. So this is a circuit. Analog circuit means a circuit which process or which deals with analog signal, or we can say analog input. So in this subject we will discuss about circuits which deals with analog type of inputs. In this subject we will discuss about circuit which process analog type of signal. So now the next question should be arise in mind that what is the meaning of this analog signal or analog input. In brief, we can say in a representation, if infinite number of values are possible, then that representation is called analog representation. We can we can understand by some example. Suppose we are asked to measure temperature of a room starting from 6 a.m. to 10 a.m. and we measure temperature of the room for every moment, and suppose at 6 a.m. it was 8 degrees centigrade, and while going from 6 to 10 a.m. temperature was rising like this. It is an assumption. Just assume that this type of behavior is showing by temperature. And suppose at 10 o'clock this was around 15.2 degrees centigrade temperature. So we can see easily that between 8 and 15.2 degrees centigrade temperature, infinite number of values are possible. We can get 8.81, 8.12, 8.13, 8.14, like 15.1, 15.19, 15.2, like this. So if this type of representation is shown by some measurement, then this type of representation is called analog representation. Means a representation which can show infinite number of possible values are called analog representation. So the signal which represents its behavior by infinite number of possible values, the signal is called analog signal. In the similar way you can see sine wave. Sine wave is showing infinite number of values between 0 and this particular maximum, suppose 5 volt, with respect to time. So this signal will be called analog signal because an infinite number of values are possible between 0 and 5. Similarly in this signal also, between 8 degree centigrade to 15 degree centigrade, infinite number of values are possible. Not infinite value, not infinite in value, infinite number of values are possible. That this type of representation is called analog representation, and the signal which represents its behavior in this manner, means analog manner, is called analog signal. It can be more clear if we discuss about what is meaning of digital signal. Then suppose we are measuring a temperature of a room, and we are seeing that if temperature is greater than 10 degrees centigrade or lower than 10 degrees centigrade, and suppose we show by 1 if temperature is less than 10 degrees centigrade, and show by 0 if temperature is greater than 10 degrees centigrade, or we can say in different manner, if temperature is less than 10 degrees centigrade, we represent by 0, and if it is greater than 10 degrees centigrade, we represent it by 10. So suppose at 8 o'clock we got temperature 10 degree, and before that we get temperature less than 10 degree. So before 8 am the temperature will be shown by 0, and after 8 am it will be shown by 1. So in this representation only two type of levels are possible, 0 and 1. So this type of representation of signal is called digital signal. So digital signal means a signal which is represented by some definite number of values. Here only two values. Then it will be called digital signal. If the signal is defined by some three levels of values like 0, 1 and 2. So this type of signal is also called digital. This is amplitude, this is time. In this representation there are three only possible values, 0, 1 and 2. This signal is also digital signal. This signal is analog. This signal is analog. This is digital. This is digital. One more thing we can see, in all these signals, values or signal are defined for every moment of time. Every moment of time. Every moment of time. So these signals are also called continuous signal. So these two signals, 1 and 2, are analog. These two signals are analog continuous signal. Continuous signals. And these two signals are digital. These two signals are digital continuous signal. So analog and digital are defined on the basis of value on vertical axis, and continuous is defined on the basis of horizontal axis. So if signal is defined for every moment of time, it will be called continuous, and if signal is defined, a signal shows infinite number of possible values, it will be called analog continuous. If signal represents some indefinite number of values, it will be called digital. One more type of signal can be explained here, that is discrete. Suppose a similar signal is defined for some particular time moment. Suppose you are asked to measure temperature in the period of 1 hour. Suppose you have measured temperature at 6 am, it was 8 degrees centigrade. Then you measured this temperature at 7. Suppose it was 9. At 8 it was suppose 10. And similarly at 9 and then at 10 it was 15.2. So the possible values are 8. At 7 degrees centigrade, suppose it was 9.12. At 8 degrees centigrade, suppose it was 10.1. And similarly at 10 it is 15.2. So we have measured at only 5 moments, 1, 2, 3, 4, 5. We have measured values at only 5 moments, and we can see any type of values is possible. Any type of value is possible, not definite value. but it is measured at some particular moment of time. So it will be called analog with respect to vertical domain, but with respect to horizontal domain it will be called discrete because it is defined for some discrete moment. So this signal is called analog discrete signal. This signal will be called analog discrete signal. Analog means it shows in different values, any value can be possible. We cannot predict. That's why it is called analog. And discrete because it is defined for some particular moment of time. And if the same pattern is defined at some particular moment of time, suppose at 6 a.m. temperature is less than 10, we represent by 0. At 7 a.m. it is again represented by 0. At 8 a.m. again it is represented by 0, but at 9 it is represented by 1. At 10 it is represented by 1. So again this signal is discrete, but in this signal only two types of values are possible, 0 and 1. 0 and 1. Then this type of signal will be called digital because two values are possible, but discrete because it is defined for some only specific moment of time. So in this discussion we can see there are four type of signals. This one analog continuous signal. This is also analog continuous signal. This is digital continuous signal. This is also digital continuous signal. But this is analog discrete signal. And this is digital discrete signal. So in summary we can say there are four type of signal: analog continuous, digital continuous, analog discrete, digital discrete. Continuous is defined on the basis of time domain, and if the signal is defined for every moment of time it is called continuous, and if signal is defined for at only specific moment of time it is called discrete signal. And for analog or digital, when signal can have any possible value, or we can say infinite number of values are possible, it is called analog. And if some definite values are possible, it is called discrete. So the circuits which deals with analog signals, are called analog circuits, and the circuits which deals with digital signals are called digital circuits. As you know, digital circuits includes AND gate, OR gate, flip-flops, etc. In this subject, we will deal with circuits which deal with analog circuits. And as we are dealing with trade electronics and communication engineering, so the most of the devices and components in the circuit will be related to electronics, or we can say will be related to semiconductor devices. So the next question arises, or next point is to be discussed is semiconductor material as well as devices based on semiconductor material. So in next lecture we will start from semiconductor. Thank you.